Okay guys, so this is Brady explains how to convert a full equation into an ionic equation. And just to clarify, there's also things called ionic half equations. That's not what we're going to be doing today. We're going to be going from a full equation to an ionic equation, not an ionic half equation, which is slightly different. So this is, well, you definitely need to know this at A2, but you would also need to know this at AS. So you'll first come across this right near the start of your AS course. So it's quite important you know how to do this from the very beginning, otherwise it'll get you tangled up when you try and do many other different things. So it's a dead simple process. All there is 3 steps to it once you've got your full equation. So I've got 2 examples here. I'll just go through this first one first. So this is my full equation. I've just got an acid and a base, and that is changed into a salt and water. And you'll notice I've put all my state symbols on. So AQ just stands for aqueous. That basically means dissolved in water. L is liquid, and I've not got them on here, but obviously S would be solid and G would be gas. So step 1, in order to change my full equation into my ionic equation, is I look at all of my ionic aqueous compounds. So it has to be ionic and it has to be aqueous. So if it was an ionic solid compound, that's not what I'm talking about. Only aqueous ones do this. And what I do is I break down my ionic aqueous compounds into the different ions. So let's have a look what I've got here. I've got sodium hydroxide, that's ionic, and it's also aqueous. So I'm going to break that apart into Na plus aqueous, OH minus aqueous, and that's that. I've also got my acid. Now, as all acids, all aqueous acids, will also break down into their ions. So this will break down into H plus aqueous and NO3 minus aqueous. If you're not sure why that's got a minus charge there, then A, you've not learned your molecular ions, so nitrate, sulfate, hydroxide, all of those. You've got to learn those charges. If you go to my college, well, they've given you a sheet in the very first week with all of those molecular ion charges on the back. You've got to learn those off the top of your head. If you don't though, if you do forget, you can kind of figure it out, because if this is H plus, and I'm removing a H plus, that must leave this with a minus, because the overall charge is 0. Same thing here, sodium is plus, OH is minus, that's why the overall charge is 0. But you should learn those off the top of your head. I'm going to do the same to the other side. So I've got my sodium nitrate, that's aqueous and ionic, so that's going to be Na plus aqueous and NO3 minus aqueous. And I've got my water, well, that's not ionic, but even if it wasn't, that wouldn't make a difference, because water is liquid, it's not aqueous. So I would keep that as it is. So if it's not an ionic aqueous compound, I don't do anything to it, I just leave it the same. So that's step 1. Step 2, I need to cancel out my ions that are the same on both sides. I suppose not just ions, you cancel out anything that was the same, but they tend to be ions. So you can see on each side I've got an Na plus, so that'll cancel. On each side I've got an NO3 minus, so they'll cancel. And then step 3, I don't leave it like this mess. I rewrite it without my cancelled out things. Now, just to save a bit of time and space, I'm just going to rub out the things I've cancelled out. And that will leave me with my final ionic equation. OH minus add H plus goes to H2O. Let's put this a little bit closer. And that's my ionic equation. I'll do the same for this one. What would probably be better actually is if you stopped the video now, had a go at doing that one yourself, then you can check your answer against mine. So stop it now if you want to have a go yourself. And the answer is, well, this is aqueous ionic, it's an acid, so that'll go to 2H plus, aqueous. It's going to 2H plus. This would not break apart into H2. That's not what happens, because if I look at this molecule, this is an SO4 ion with a charge of 2 minus, bonded to a H plus ion obviously doesn't look exactly like that, I'm simplifying, but bonded to two different H plus ions. So this is not an SO4 2 minus bonded to a H2. That's not what it looks like. With all acids, your H's are bonded, or they're released as H pluses, even if you have two of them. So I've got my two H pluses, and let's not forget my SO4 2 minus. I've also got, let's break this apart, my Mg2 plus aqueous, and I've got two hydroxides here. Again, this magnesium hydroxide would look like this. Something along those lines, these bonds here. So it's not like they come off as O2H2 or anything like that, or it doesn't come off as 2OH minus, I don't know how else it would look, but the way it has to come off is as separate molecules, so two OH minuses, where each OH minus is separate. And again, that's aqueous. And then on my other side, I'm going to have my Mg2 plus, my SO4 2 minus, and my 2H2O. Again, I'm not doing anything with the H2O, because that's just a liquid. And it's not ionic anyway. So let's cancel out. So SO4 2 minus, SO4 2 minus, Mg2 plus, Mg2 plus. In the exam, you'd rewrite it. Like I say, I'm just going to rub it out to save space and time. What does that leave me with? 2H plus add 2OH minus goes to 2H2O. And we can even simplify this a little bit by dividing both sides by 2. So H plus OH minus goes to H2O. Now I've deliberately done these two examples for a reason. These are both acid-base reactions. And what do we notice about both their ionic equations? Well, they're the same. In this one I've done these the opposite way around, but they're actually the same. So that's actually true for any acid-base reaction. If ever you're asked for the ionic equation for an acid-base reaction, it is always this. That's what's actually happening when you react an acid with a base. Okay? I'll just, if you feel happy with that, you might want to stop the video now, but I'm going to go through two more, slightly more difficult examples, not really that much more difficult, if you wanted to get really, really good at this. So give me 2 seconds to write them up. Okay, so. Again, if you're not sure about where these equations come from, don't worry too much about that. You will learn all of these equations as you go throughout the course. All we're focusing on now is just converting this equation to the ionic form. Okay, so that's our first one. Okay, that's our second one. So again, if you want to stop the video now, have a quick go at these two. They're not harder, but we've just got maybe someone which might trip you up on. And then once you've done that, restart it and I'll go through it. Okay, so here's how I would go through it. So let's break apart my ionic aqueous compounds. So Ag plus aqueous, NO3 minus aqueous. And then I've got my, right down here, K plus aqueous and Cl minus aqueous. It's all going to go to I'm actually going to keep this as AgCl. And the reason I'm going to do that is because this is not an aqueous ionic compound. This is a solid ionic compound, so I don't break it apart. I need to keep it the same. Only aqueous things will break apart into their ions. Solids will stay as a solid, so they stay grouped together. And that's why it's a solid, because it can get build up and get bigger and bigger. And this is an aqueous ionic compound, so this will break apart. Okay, just like before, I'm going to cancel my ions out. So K plus with K plus, NO3 minus with NO3 minus. Rewrite it without my cancelled out stuff. And what am I left with? Ag plus and Cl minus goes to AgCl solid, and we'd call this a precipitate. This would be a solid precipitate. Okay, be a cream precipitant. Yeah, your white precipitate. Oh, I'm rubbing this off now as well, what we're doing. So our final one. Here, again, I'm going to break apart my aqueous ionic compound. This is aqueous, but it's not ionic, so I'll need to keep it the same. So Cl2 aqueous. This is ionic, so this will give me Mg2 plus and 2 Br minuses. Remember, this wouldn't be released as Br2 because that's not the way they're joined together. They're actually separated, one either side of the magnesium. So when they're released separately as separate ions. So 2 Br minus. And all that, again, this is aqueous ionic. I'll go to Mg2 plus aqueous, 2Cl minus, aqueous. And again, this is an aqueous one, but this is not an ionic compound, so that'll stay as it is. Cancel out all the ones that are the same. Well, Mg with Mg, and that's actually all I've got, which is the same. So what does that give us? It gives us an ionic equation of Cl2 plus 2Br minus goes to 2Cl minus and Br2. And that is how we convert a full equation into an ionic equation.